Okay, here we go. I'd like to begin by thanking everyone for joining me for this talk today. And before we jump in, I'll share a bit of my background. So again, my name is Mandi, and I've been developing with GraphQL since 2017. And I started teaching other people how to use GraphQL shortly after that at a tech and design school I used to work at. Last year, I decided I wanted to consolidate everything I had learned about building GraphQL APIs over the years into a book, and I called that book Advanced GraphQL with Apollo and React, and I self-published it earlier this year. Now, today, I'm going to give you a quick rundown of how you can handle auth with your GraphQL API. And my intention for this talk is to give you an overview of how we can handle authenticating and authorizing users with GraphQL APIs. And specifically, I'm going to show you how this can be accomplished using various libraries, including Apollo Server, and we'll even talk a little bit at the end about how this works with Apollo Federation too. Now, before we dive in, it's important that we clarify what we mean when we talk about auth, and there are two sides to this. So first, we have authentication, which helps us identify that a user is who they say they are. And once authenticated, we want to make sure that users are only doing the things that they're allowed to do with our API, given their assigned roles, groups, or permissions. And this is what we refer to when we talk about authorization. Now, a good place to start when deciding how we're going to handle auth with a GraphQL API would be to go to the GraphQL spec itself to see what it has to say about how we should best move forward. And on the topic of auth, the spec has this to say. Or perhaps more accurately, it doesn't say anything specific about authentication or authorization at all. So since we're choosing our own adventure here because there's no spec mandated way to manage auth with a GraphQL API, we can instead draw from a collection of tools and battle-tested practices that have emerged over the years that will help guide us towards locking down our GraphQL API with confidence. So let's start with authentication. I find that a demo is often worth 1,000 slides, so I'm going to quickly set the scene here and then take you through some code examples so we can see some of these concepts in live action. So first of all, we're not going to lock down our entire GraphQL API endpoint. We're typically going to want to authorize user access to our API on a per query or permutation basis, and perhaps may even want to manage access more granularly on a per field level. Our second assumption is that we're going to use token-based authentication, and specifically, we'll use a JSON Web Token, or JWT for short. But you could use a similar approach with other kinds of tokens too. Finally, we're going to use Express with Apollo Server because it will simplify the JWT handling and verification process with some ready-made middleware, but it's not explicitly necessary to use Express or any specific kind of node middleware to do this. Now, one last thing before we jump into the demo. If you're new to JWTs, a typical JSON Web Token will look something like this. And if you look closely at the string of characters, you'll see that it consists of 3 parts that are delimited by periods. First, we have the header, and the header will typically contain the token type and the algorithm used to sign the token. In the middle, we have the payload, and here we'll find claims about a particular entity, and the entity that we're dealing with in our case will be a user. Now, the JWT specification has some predefined registered claims, and we can see examples of those here in the form of the issued at time, the expiration time, and the subject claim, which for us refers to the user's unique ID. And we can also add some custom claims of our own to a JWT in the form of public or private claims. And we're going to add a private claim to our JWT, which will namespace using the URL of our GraphQL API. Lastly, we have the signature, and this part of the token helps us verify that no information was changed during the token's transmission by hashing together the token header, its payload, and a secret. And we can see an example of how that might be implemented here in pseudocode. Now, as a final note, even though a JWT may look encrypted, it's just base64 encoded to make it as compact as possible for transmission, which means all of the information inside can be just as easily decoded again. So it's important not to put any secret information inside of the JWT header or payload. All right, we're ready to jump into our demo. So jumping into VS Code, you can see here that we have a very basic Apollo server setup using Express. And in our type definitions, we have a single object type defined here called user, along with a corresponding query to get a single user by their ID. And in our resolvers, we can see that we're pulling some mock data from a file called data.js. And in that file, we have two different users, and each of them have different roles and permissions assigned to them. And of course, for demonstration purposes only, we have their passwords hard-coded here in clear text. Now, our first step is going to be to add some JOT checking middleware to our server. And for that, we can use a package called ExpressJOT, which I have already installed. So if we go ahead and run our first step here, I'll highlight the code so we can see what changed. So for this step, we can see that we've now imported the middleware, and we call that ExpressJOT function and pass in a secret string to sign the JOT. And again, for demonstration purposes only, we're adding the sensitive value directly into the file, but typically we would store something like this in an environment variable. We also specify the signing algorithm to be HS256, which is a symmetric signing algorithm, meaning that we'll need to use this secret both when we create a user's JOT and when we verify it. And lastly, we set the credentials required option to false, so Express won't throw an error if a JOT hasn't been included, which would be the case when a user initially logs in or potentially when GraphQL Playground polls for schema updates. And if you're wondering what kind of magic is happening under the hood here, the middleware we just added to Express will get the token from the authorization header of an incoming request, decode it, and then add it to the request object as a user property. Okay, we're ready for step 2 now. So I'll go ahead and add that code. And if we scroll down, I'll highlight the code changes, and we can see that we're now taking advantage of Apollo Server's context option. So once the middleware has added the decoded token to the request object, we can use Apollo Server's context to pass this data down the graph to the resolvers. And it's a common practice to add decoded tokens to Apollo Server's context because this object is conveniently available in every resolver and it's recreated with every request, so we won't have to worry about tokens going stale. So here, we check for the user object in the request and add it to the Apollo Server context if it exists. Otherwise, we just set user to null because we don't want to error out if a token isn't available. So now that we can handle an incoming token, we need a way to create one in the first place when a user wants to log in. And this actually brings us to a very big question. Should authentication be handled within the GraphQL server itself, or is this out of band? Now, some people say we should leave authentication entirely out of the schema. In other words, we shouldn't have login or logout mutations. And that would mean we just have the decoded token data available in the context, and we leave it at that. And I would say in practice, there's a very high likelihood that you would want to use some kind of dedicated auth service, and perhaps even use something like Auth0 to manage your app's authentication needs. But to keep things simple, let's implement a login mutation here so we can get a sense of how the JOT would be created. So we'll move on to our third step, and I'm going to jump over to our type definitions. And now that the code has been added, we can see that we now have a mutation here for logging a user in. And that mutation takes an email and a password as arguments because we're just going to use password-based authentication for this API. You'll see that our login mutation also returns a string type, and that string is going to be the JSON web token that we create inside of the resolver. Now, moving on to our resolvers, we'll take a look at what just changed here. And you'll see that to log a user in, we find the user in our database whose email and password match the incoming arguments, and then we use the JSON web token package to create and sign a JOT for them. And the first argument we pass into the sign method is an object containing the JOT information we want to add to the payload of the token. And because we're adding some custom info as a private claim to this token, again, we namespace it using the URL of the GraphQL API as a property with the user's permissions and roles inside of an object as a value. As a second argument to the sign method, we also have to pass in the same secret that we used before to verify our tokens. And as a third option, we can also pass in some additional data such as the unique subject value for the token, which again is the user's ID, and a token expiration time and the signing algorithm we want to use. All right, we have one last step to run before we can try out our API. So I'm going to hop back over to our type definitions, and we can see here that we've now also added a viewer query. And this query is going to allow us to retrieve an authenticated user's information based on the data in their token. And as a little sidebar here, it's a good practice to expose a viewer query that acts like an entry point for what authenticated users can do with your API. And if we were to fully realize that here, we could add a viewer object type to use as the return type for the viewer query instead of using the user type, and then expose fields on that type that allow an authenticated user to query for relevant data. Now, that's a bit out of scope for what we're doing here today, but I encourage you to take a look at the GitHub GraphQL API for a working implementation of this. Now, lastly, over in our resolvers, we can see that in the resolver for this query, we get the currently authenticated user's information by using their ID value, which is available in the subclaim of the decoded token in the context object parameter. So with this code in place, we're ready to try out our API. So let's hop over to GraphQL Playground. And in GraphQL Playground, you can see that I've set up a login mutation to log in our Neil Armstrong user. So if we go ahead and run that mutation, we can see that we do in fact get back a JSON Web Token in the response. So I can go ahead and grab that token, copy it, and hop over to a viewer query here. And in the HTTP headers panel here, I'm going to add an authorization header. And I'm going to set its value to be a string, which starts with the word bearer, has a space, and then is preceded by the JSON Web Token. And we can go ahead and run that query, and we see that as we expect, we get back the Neil Armstrong user. All right, this is looking pretty good as far as logging in users go. But before we can finish locking down our GraphQL API, we need to understand a few things about authorization. Because while we now have a way to identify users based on their tokens, we still don't have any mechanism to limit API access to authenticated users. And this is where authorization comes in. Now, the most basic level of authorization is letting users run queries based on whether or not they're authenticated. And we're going to do this, but we're also going to add finer-grained authorization to our queries based on the permissions in the logged-in user's JOT. Now, when adding authorization to a GraphQL API, we have a few different options at hand. We could directly check the authenticated user's ID and permissions inside of each resolver, but this wouldn't be very dry, so let's just count that option as off the table. Instead, one popular option for adding authorization involves adding custom schema directives to control access to various types and fields. Alternatively, we could use a package like GraphQL Auth to wrap our resolver functions explicitly with permission checks. Or we could use a package like GraphQL Shield to completely abstract the authorization rules into a middleware layer. And for our API today, this is what we're going to choose. Now I'll jump back over to VS Code here. And the first thing we're going to do is run our next step. And when this code is added, we'll see that we now have a new file called permissions.js. And this file is going to be where we manage all of the authorization rules for our API. And before we import and use anything from GraphQL Shield, which I've pre-installed, you'll see that we've created a little helper function here that we'll use to check if a decoded user token has a particular permission applied. And if I go ahead and run our next step, you'll see that we import a few things from GraphQL Shield that are going to help us apply authorization rules to our schema. And first, we're going to focus on the rule function, which has the same parameters as a typical resolver function, including the context. And we're going to use this rule function to, not surprisingly, create an authorization rule. And the first one that we create here allows us to check if a user is authenticated by verifying that the decoded JOT is present in the context. And how this rule function works is that if we return false from the rule, then the authorization will be denied. So now we can add some more complex rules that will help us check if particular permissions have been assigned to a user. And if I scroll down here, you'll see that the can read any user and can read own user rules each check for their corresponding permissions and return false if they don't exist. And we also have the is reading own user rule, which verifies that the ID of the user requested from the query matches the ID of the authenticated user. Now we're ready to add the final bit of code to this permissions.js file. And when we do, you'll see that we now call the shield function. And into this function, we pass an object whose shape mirrors our resolvers. So for the viewer query, we only require that a user is authenticated to run that query. But for the user query, we employ the logical and or functions provided by GraphQL Shield to check a more complex configuration of rules. So for this case, we allow a user to run the user query if they're requesting their own user and have the read-own user permission assigned to them, or alternatively, they can view any user if they have the read any user permission assigned to them. Now, last but not least, we have some updates we need to make to our index.js file to actually add these permissions as middleware. So when we run those changes, you'll see that we now must import a few new things into this file, most notably the apply middleware function from the GraphQL middleware package, as well as the permission roles we just created. And if I scroll down, you'll see that we've also updated our Apollo server config so that instead of passing in the typedefs and resolvers directly, we use the schema option instead and set it to the value of calling apply middleware and applying those permissions to our schema. With this code in place, we're now ready to jump back over to GraphQL Playground. And if I grab the authorization header that I used for my viewer query, I can paste it into the HTTP headers panel for the user query. And if I run the query using the ID of the currently authenticated user, you'll see that we get back the Neil Armstrong user information as expected. However, if I run the query using the ID of a different user, we get back a not authorized error message, as we might expect, because this user does not have the appropriate privileges to view any user's account. And that's it. In just a few short minutes, we've now successfully added both authentication and authorization to our GraphQL API. So to wrap up, I'll jump back over to my slides here. And before we conclude, I'd like to briefly touch on how we could approach handling auth when dealing with a federated data graph. And the good news is that everything we just covered can be applied to the Apollo server that you configure at the gateway level of your API. So in other words, you can extract the token from the request and apply it to the Apollo server context just as we have. And we only need to do a small amount of additional configuration to pass that incoming token data along to any implementing services. So to do this, when configuring the gateway, we can make use of the build service option to extract the decoded user token from the gateway API's context and then forward it on in the headers of the request to the implementing services. Then, in the Apollo server constructor for the implementing service, we can once again extract the user from the request headers and add it to the context for that Apollo server. And we don't need to worry about verifying the JOT again here, because that would have already been done at the gateway level of the API. Okay, so that was a bit of a whirlwind tour of handling authentication and authorization of a GraphQL API's queries using Apollo server. And specifically, we saw how we can handle incoming tokens and apply them to the Apollo server context. We also learned that a viewer query can act as an entry point for authenticated users in your API. We also saw how we can keep authorization checks directly out of resolver functions to keep this layer as thin as possible and abstract those permission checks into a middleware layer. And lastly, we got a sneak peek of how we can forward an incoming token from a gateway API onto an implementing service using the build service option in the gateway config. Now, if you'd like to see the complete code for this presentation, you can find it in the first repo listed here. And if you'd like to see a more extensive example of how to add auth with Apollo Federation, I'd recommend checking out the second repo link. And finally, you can see an example of how to handle auth with a GraphQL API using passwordless authentication and a decentralized identity token in the third repo. Okay, so thanks again so much to everyone for coming today, and I'd be happy to take some questions now. Hi, everyone. I have some time to take a few questions now. So I see a few have come in here. The first one I'll tackle is in the login mutation. What if I need to redirect a user? So that one came in from Twitch. And to that, I would say if you need to redirect a user after a login mutation, then this is likely something you're going to want to handle client side after the mutation has successfully completed. So that's going to be completely dependent on your specific use case with what you're doing with your client. We have another question here. When it comes to auth, is it better to lock down the whole API and have users hit a different endpoint to log in? Or do you think it's fine to have a public mutation? And this question came in from Kurt. So again, I'm going to say it depends. But I would say what I've typically seen with respect to login mutations is that these mutations have been public. But I would qualify that with also saying that when I'm adding authentication and authorization to a GraphQL API, I am most typically using a third-party service like Auth0, for instance, to handle all of those authentication concerns completely outside the context of the GraphQL API. And then I control access to the API using middleware like GraphQL Shield, like you saw in the talk, to then parse those permissions and roles as needed throughout the schema on a per field or per type basis. All right, so we have another question here from Kurt, which is, what are your thoughts about allowing introspection of auth GraphQL APIs? So I would say it's probably almost certainly a good idea to shut off introspection in production. So if at all possible, leave introspection off. Let's see what else we have for questions here. Over to Twitch. Let's see. So here's an interesting one from Arval. What do you consider to be the key advantages of using GraphQL Shield over using auth directives? And I would say, and this is perhaps a matter of personal preference, but I really like when the authorization rules are abstracted away from the schema and like completely away from the type definitions so that they can be handled separately in their own layer. So perhaps if you are building a schema where you feel like it's okay to have those kinds of authorization rules intermingling directly with your schema in the form of those directives, that's fine. But for me personally, I like to have all of my authorization rules completely abstracted away into a separate layer. Let's see what else we have for questions here. So here's a question from Cindy. How does field level auth look like? Do you recommend responding with a per field error? So that will depend on what route you take with respect to handling authorization rules in your schema. With GraphQL Shield, as was demoed in the presentation there, they kind of take an all or nothing approach to delivering an error to a user. So if some kind of error occurs, you get a generalized not authorized message. So it's, I guess, a bit ham-handed in that sense. You can customize the error. There is some mechanism in the API to do that. But it is kind of one size fits all in terms of delivering people errors. So again, if you need more granular reporting as to like what kind of authorization error might have been triggered in your query, then you might want to take a different approach there. Let's see, what other questions can we tackle here? So there's another question from Kurt here. What do you think about using scopes for finer grained authorization? And yes, again, that's from Kurt. And I would say that depends on your use case as well, and just how you need to build out permissions and roles and groups and whatever else you might need to account for on the authorization side of your authentication service. So again, I find it a bit tricky to answer that question in a generalized way. So I'll say it depends for that one as well. Let's see. Let's do one final question here. So I have a question here, and I apologize if I mispronounced the name, but I think it's from Reagan. And the question is, at the initial load of Playground, how does the system allow for mutations with a token? So as far as the example goes that I showed in the presentation, that's something that needs to be manually added into the authorization header and the HTTP headers of GraphQL Playground. Okay, so that's about all the time I have. So we'll have to wrap it up here. Thanks so much, everyone.